Hello, welcome to my video. I'm a high school student who's learning Edexcel at level FP1 and FP2. Many of my classmates have been asking me about imaginary numbers, so in today's episode, let me break down the conception of imaginary and complex numbers to you. I promise that after learning my video, you will understand these two confusing conceptions. To understand the conception, we need to understand from two perspectives. Firstly, how imaginary number exists. Its existence needs to be justified. Secondly, how to express it. We need to know its form of existence. Further, I will introduce these three forms of a complex number. Of course, I will justify them. Okay, let's start with something that you are familiar with. Real number. Firstly, let's set up a real number line with a point x at 2. Now x coordinate times 1 to the first power. How does x behave? It sounds like nonsense. It's quite easy. Clearly, the position of x remains. Now the condition changed. What will happen to x when its coordinate is multiplied by -1 to the first power? It's quite easy. 2 times -1 equals to -2. However, in the language of geometric rotation, we can consider that x rotates around point 0 for 180 degrees. Now let's introduce the conception of imaginary number. What will happen to the coordinate of x if its coordinate is multiplied by the square root of -1? Before answering that, we find that root -1 can't be defined on a real number line. That's what imaginary number exactly is. We use letter I as its symbol. The square root of -1, in other words, is the -1 to the power of 1/2. Since we consider x times -1 to the first power as x rotates around 0 point for 180 degrees, through the same logic, we can consider that in this condition, x rotates around 0 point for 90 degrees. Now x coordinate is 0, 2. Now x value is 2i, and we define that x is an imaginary number. In addition, look at the graph. The Cartesian plane, which consists of a real number line and an imaginary number line, is defined as a complex plane. Now we introduce a point z which is not on either axis. When we want to represent the coordinate of point z, we say z is at 2, 2. We want to represent the value of complex number z. We say z equals to 2 plus 2i. Yes, if any number consists of both real number and imaginary number, we call them complex number. Look at the title of the slide. Now you've learned the fundamental form of a complex number. Now let's start exploring the second form of a complex number. A point z at 2, 2 is introduced. An angle is formed by a line through 0, 0 and 2, 2 and the positive real number axis, which is shown in the slide. We can find the magnitude of this angle by calculating arctangent 2/2 equals to 45 degrees. Now I need you to imagine a motion on the plane. The segment OZ is rotating about point 0 anticlockwise. Look at the graph on my slide. OZ has now rotated for 45 degrees, 60 degrees, 120 degrees, and so on. But it can also rotate anticlockwise. When it rotates clockwise for 135 degrees, we record a negative 135 to represent its direction of rotation. Now we've learned that how to represent the direction of a point to 0, point in a complex plane. The angle we recorded is called the argument of a complex number. For a complex number, we can find three facts. That's the value, the coordinate, and the segment property of ZO. Now that we've known that ZO is a segment, we can calculate the length. In the other words, the distance from O to Z. The absolute value of Z means the distance from Z to 0. It's called the modulus of Z. Since we know the distance and the direction of a point from 0, we can find its position through a formula. That is, Z equals to its modulus times the sum of the cosine value of its argument and I times sine value of its argument. Use the knowledge of trigonometry and expand the value. You will easily find that it equals to A plus I times B. And this formula is the modulus argument form of a complex number. The third form is exponential form. Z equals to R times e to the power of I theta. And I actually decided to prove it, but it's really troublesome. It's involving other important knowledge of further math too. If you are really curious, waiting for my next video.